Alright, time for another draftphysics.com, debatephysics.com. But again, can't find a really nice, fair, disciplined debate to be had. Nobody will show up to complement my arguments with a counter argument explaining where I say something that's completely incorrect and the whole argument is therefore defeated and blah 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 blah. So nothing like that can happen. And again, I have for probably 2 years been saying things like, do you really believe it takes 25 times the fuel, the energy, to spin something 5 times as fast? Do you think it takes 25 times the gasoline, you know, compared to going 10 miles an hour, going 50 miles an hour? That you'll use 25 times the fuel to go 50 miles an hour than you'll use to go 10 miles an hour. Come on. It doesn't make any sense. It can't be true. And it has to be true if the kinetic energy theorem has anything to do with reality. It has to be true. Alright, and so I can point out that the Mythbusters, in a rather clinical experiment, I mean, they had a device that kept the speed constant. They took real cars, okay, and just for the showiness of it, smashed them, okay, into a steel, a brick wall with steel in front of it. And yeah, the 50 mile an hour crash, this much, the 100 mile an hour, twice as much. No 4 times the damage. Just a fact, 2 times the damage, that's it. Kinetic energy demands it's 4 times the damage. And it also demands, again, that it's 4 times the energy to do it. And I suspect you could prove with the electric bill that it didn't take 4 times the electricity to make the car go 4 times as fast. I mean, twice as fast. So, that's a piece of evidence. I worked in a machine shop, blah, blah, blah. I can point out that, played sports. There's no way, okay, that there's any kinetic energy in those realities. And then I can go through all the experiments where if you try to collect the kinetic energy, you can't. So you have the classic ballistic pendulum. Bullet goes in with 2,000 joules. All you collect is 2. All you collect is the momentum. Can't collect anything else. So, I mean, what's the point of energy you can't collect? I pointed out with a spaceship. You hit the spaceship with a bullet. Not going to do you any good. Just going to get 2 joules. You're not going to get 2,000. You're going to get the same joules that if you had 1,000 atoms going 1 mile an hour, or you have 1 atom going 1,000 miles an hour, you're going to get the same frickin' push out of it. You're not going to get any kinetic energy. So they can't show me an experiment where they actually collect it. And it's just a fable. And people are pushing it so aggressively and keep defending it, and they can't answer the question. Because if they answer the question honestly, do you really believe it takes 100 times the fuel to go 10 times faster? You really think so? And I know you don't. And so why are you defending it? I just don't understand why you would defend something has to be broken. And it has to be broken like really substantially, because you can't show me the experiment where they collect this stuff. You can't show the 8-pound bowling ball going 16 miles an hour knocking down twice the number of pins. You can't show anything, of a 16-pound ball going 8. You have nothing. And I've shown you that, levers say a different truth is true. All these other experiments. So I'm just, I can't understand why you people are such liars and defenders of rubbish, garbage ideas. Ideas that just can't be true. And like I said, if there's a grain of truth, you have to concede, okay, well, something's wrong. Maybe it can be fixed. But if you don't know how to fix it, or you don't know somebody who can fix it, you have no business still selling it. It's a lemon, and you're selling it. You're selling frickin' mental poison. And you should be ashamed of yourselves to just keep defending it without any good arguments. Alright, so I'm going to talk about gravity again, because that's where this all starts. Leibniz's kind of pitiful understanding of gravitational force. Because they didn't know what it was. None of them did. Newton didn't know what it was. Now, Fadio had a good idea. Newton liked it for a while. But that does create a conflict with other realities, and certainly the drag issue was a real issue to bring up. But it does have a solution, but they didn't really think about it long enough to find it. So leave us go to the drawing again. So this is all just simple Galilean observations, and and it's I just don't know how you can argue around it. It's just so kind of, that's how it works. I don't know what you're talking about when you talk about it doing something else. So the classic Leibnizian axiom is that you can drop 4 pounds 1 foot, or you can drop 1 pound 4 feet, okay, and you have the same energy. Okay, so 4 units of distance in gravity equals 4 units of energy. That's what you collected. Now, obviously, it doesn't sound quite right because you only got 9.8, plus 9.8. You only got 16 when you hit the ground, right? A little tired. That's no, 16. That's not right. 9.8 plus 9.8 is 19.6. Yeah, that's the one. So you only got 2 units of velocity, and it's only 2 units of time, okay, which I've pointed out over and over again. So this took 1 unit of time, and this whole part took 1 unit of time. Okay, 1 plus 1 is 2. Okay, so Galileo did all of this. This pen is croaking. So we'll dispose of it. Well, okay, I didn't do that very well. Because I'm a little incompetent and throwing things over my shoulder doesn't mean I'm wrong. Okay, 2 units of time. Wow, that's really fantastically bold. All right, so the trick is, okay, that this is, let's say we did this in 1 unit of time. So we're going to drop this in 1 unit of time, and it'll only drop 4.9 meters of distance. Okay, and it'll end up with 9.8 meters of velocity when it hits the ground. So that's the idea. And so here, this would only be 4.9 units of distance. But it has 9.8 velocity now. Okay, so when it gets to this point, it's going 9.8. And because it had to accelerate from 0, it's increasing its velocity. It increased it by the same 1:357 ratio. But anyway, it took a time to get up to speed, and that's why it's only 4.9 meters of distance. Now, if I cut the gravity off right there, okay, so let's just say I could turn gravity on and off, and I turn it off right there, it's going to keep going 9.8, and I'm not going to have to add any more energy. So without adding anything, it's going to keep going 9.8, right? So just understand, after just traveling 4.9 meters, it will be going 9.8, and it'll continue doing that forever, so to speak. If I could just turn gravity off and give it and it was just flying through space. All right, so what's going to happen here? What's the trick here? So we know it's going 9.8, so we already know it has that velocity. So if I turn gravity off, we know at the second, so after I go another second, it would go to here, okay, with gravity off. So with gravity turned off, after the second, it's going to be here. So this will be 2 units of time, and it will still only have 9.8 units of velocity, though, because 9.8 means 2 of these 4.9s you could basically figure out, right? so anyway, so it's going to travel to 9.8, and so you're going to get these 2 for free. You didn't have to add any energy. You're getting those 2 units for essentially free. You got that one with the first one, and so it all adds up. Okay, so that's what you're going to end up with as an object moving, and it's just going to go 9.8 again, and then 9.8 again, so it's not going to increase. But let's say gravity's on. Well, if gravity's on, this is all I'm getting right here. I'm getting exactly what I got the first time. I'm just getting 4.9 in distance. That's the only distance I'm going to get out of it for another unit of time. But what I am going to get is another 9.8 increase in my velocity. So certainly now my velocity is 19.6, so the next time I let this happen, I'm getting 19.6 for free, right? So I'm getting the full 4 units of distance for free, okay, because it's got the 19.6 velocity. And what am I going to do? I'm going to add one more. So there we go. 1, 3, 5, 7. And it just continues that way. And like I said, this is Galileo gave you this 400 years ago. And you're going to argue that somehow each one of these things, something happened? And you know nothing happened, because it happens here. Again, without adding more gravity, I end up here in 2 seconds. Clearly, this was all already built in from the first addition of velocity. This first velocity, this first acceleration by gravity, this first second, created all this. And I don't need a second of it to maintain that. And all I added is this. This is all I can add in 1 second. I can just add 4.9 meters of new distance, and I can only add 9.8 meters of extra velocity per second. And it's per 1 second. The fact that I have to keep arguing, this is per 1 second. It's not per any number of seconds or squared seconds. It's 9.8 meters per 1. And if I do less than a second, then I gotta make the number smaller. If I make more than a second, then I gotta make the number bigger. To be 9.8, it has to be just exactly 1 second. So again, you can just understand it's 4 units of distance, all right? But obviously, in the first unit of distance, you gained the velocity, enough velocity to get 2 units of distance without any added energy. So these 2 units of distance required no energy. And this is all the extra you got. And you just have twice the velocity. You don't have, and you can't have collected 4 times the energy because you only collected 2 units of energy. 2 pushes. You didn't collect 4 pushes. You just have 2. And that's all you have. And that's all the energy you have is 2 of the same exact push. So how can you get 4 times, how can you get 4 times the energy? It's impossible to make 4 times out of that. It's twice the time, twice the velocity. It makes no sense to say there's 4 times the energy because it's only twice the force. And twice the force can't make 4 times the velocity. And that's exactly what Newton said right under the second law. Twice the force, twice the velocity. 3 times the force, 3 times the velocity. And so, they keep lying about Newton, but clearly Newton understood it like this. It's a time-dependent force. You acquire units of energy in units of time, and it makes perfect sense. And it clearly tells you, okay, that when you drop 4 times the distance, most of that time now, you're going to be going fast. And the faster you go through the gravity, the less gravity can stick to you, so to speak. The faster you walk through the rain, the less rain will hit you. The less time you're in the sun, the less suntan you'll get. The quicker you move something across a paint sprayer, the less paint will get on it. It's just the way gravity is. It's a time-dependent force. You get it in units of time, not units of distance. And that's where all this starts, is they think they can conclusively prove in some way that what I just said here isn't what happens, that somehow something else is happening, that it isn't 2 pushes by gravity, it's somehow 4 pushes by gravity, and it's not. Yeah, I can't, there's nothing else to say. So again, all of this is just an argument about the fact that apparently physicists aren't very mechanically inclined, and so they can't understand, simple things like surface area and things like you can't, if I have a rubber ball and it expands at a certain speed, okay, I press it in and it expands at a certain speed. I can't obviously put another rubber ball next to it and have it expand faster. I can't put a lighter ball 10 times lighter. It won't go 10 times as fast because the ball that's expanding can't expand at the speed it needs to push that ball. So it won't collect all the energy. Simple arguments like that, they can't understand. But I mean, realistically, when you think about the 25 times the fuel to spin something 5 times as fast, and we have no evidence of it at all. We have crystal clear evidence that when cars are crashed, they show no sign of kinetic energy. And then you have that ballistic pendulum just making it so obvious to you that all you can collect is the momentum, and you collect almost all of it, a little bit short, and that's the heat that you're left in the pendulum. And you can understand, though, if I actually did collect, if I only lost 98% of the kinetic energy instead of losing 99% of it, it would mean I made free momentum. And that would be paradoxical. That would be problematic. So it can't be real, because if you could actually collect it, it would be free energy. So, come on. I just can't, look, you're the only people that can fix this. If everybody who shows up and watches these videos plays the obstinate, you just spout your Muslim crap, the truth is never going to be respected or understood or appreciated, because you're just frickin' whatever. You got your little gung-ho, you got your little plastic finger on, you're going, we're number one. And you don't want to accept that science made some mistakes. But it's an obvious mistake, and its whole history sucks. I mean, Leibniz said it. He never proved it, never showed any experimental evidence demonstrating it. All right, and then Deschardelet did the little denting clay with round things, which was kind of bogus, and clearly the rolling thing. So let me just do the rolling thing one more time, just to say, okay, yeah, it looks like. But as I just explained with gravity, you can understand why it looks just like what gravity's doing. 4 times the height looks like it's more. Okay, but it isn't. Okay, because the thing is going to be moving quicker through the force that's pushing it. Okay, so I roll a ball and it goes, with 1 velocity, and then I give the same ball 2 velocities, same mass, and it goes 4 times the distance. All right. So you're saying, well, 4 times the distance, that's 4 times the energy, because, this ground is taking the energy at the same rate, and so it loses its energy. It's got to be the right answer. It's 4 times the energy, because it went 4 times as fast. Now, a simple argument is what you should do is collect it with a spring or some other kind of mechanism. But anyway, and you have to do that before it runs out of energy, of course. This one runs out of energy really fast. This one runs out of energy really slow. And the reason is just so easy to understand. I mean, if you timed it, you'd find out that it's going half the speed here. It doesn't go half the speed at half the distance. It goes 1 velocity right here, because we already know what the 1 velocity looks like. It's right over here. So it's guaranteed. We don't even have to do the experiment, and we can at least know, all right, it has to be going 1v here, because this is what 1v looks like right here. 1v is only this much distance, so we know what 1v looks like. And so it's going half its speed 3/4 of the way down the track. So you've got to understand it. Why would it be doing that? If this was pulling energy out evenly, shouldn't it be pulling it out? Shouldn't half be here at the middle? Half? So it's obviously not pulling the energy out evenly, because the force of gravity. We got 1 unit of time here, and all of this will be the same unit of time. And again, gravity is a time-dependent force. You only get 9.8 here, and you only get 9.8 here. This 9.8 is pushing on this small surface, and this 9.8 is obviously pushing on a much larger surface. So therefore, the pressure per inch has to be much lower here than it is here. Now, I did draw an arrow, but you can't see it. And you can understand that. And so then I've used the term thin ice, just to illustrate the point. This is exactly why you can slide across thin ice and get away with it. Is because factually you'll be putting less pressure per square inch on the ice the quicker you go across it. And so there's technically, if there was friction, between you and the ice, and not just some pressure. I mean, of course, there is friction. I mean, the ice couldn't break if there wasn't some sort of idea that you're pressing on it and causing some sort of connection to it. But you've got this slick water layer on it, so you're not losing energy as quickly to the surface because there's no rough spots that you have to hit and bang into and all that kind of crap. So it's just basically the only element of the only loss there is that very small loss. You're not losing as much energy, so you'll slide even further than the four times the distance kind of thing. If I slid it across ice, it'll go further. You'll lose energy much slower. But the fact is, in the gravitational sense, it's still going to be the same pressure. So it's going to be whatever 1 second is, it's 9.8 for that 1 second. And the faster you go, again, it's just like a paint sprayer. You're spraying paint. Gravity's an unequal force. So it can be simply understood as there's pressure coming from below and there's pressure coming from above, and you're in a differential that's 9.8. So there's more paint coming down than there is coming up, and that's a simple argument. And the faster you go through that differential, the less paint, okay, the less, there's no point in saying it that way. Yeah, just think of the spray as being one way, and you're going to have less paint on you. It's that simple. So again, I've done it before, but I mean, this mechanics. Here's gravity. Here's the moon. You're going to shoot a little a satellite past the moon. The faster you go, the less you get your trajectory's bent, because the less force affected you. You went through the amount of strong gravity quickly. It didn't have time to act on you, so you got away with going past it. And if you go slow and give it more time, it hits you with more pressure and changes your path more. And eventually, if you're going slow enough, you're going to just crash right into the moon. There's no flaw in that mechanics. It perfectly describes the physical reality we see. And again, you have no physical evidence of this exponential or quadratic growth in energy based on velocity. You can't physically show me the experiment where you collect it. You can't show me the 8-pound bowling ball knocking down twice as many pins as the 16-pound ball, going half the speed. You don't have any evidence. So why are you defending, as science likers or science followers or science give-a-shitters, why are you defending a theory for which there is no evidence and a ton of evidence saying it can't be true? The lever, for example. All right. I mean, I can't, there's nothing you can say, really. I'm just, what's going to be the verdict here? You really think somebody's going to show up, a miracle lawyer is going to show up with some sort of better evidence? You've had hundreds of years to collect evidence, and it's quite obvious you can't find any. And here you are defending, again, something it might as well be a flat earth theory. It is so without evidence. It is so outside the realm of reasonable. And here you are aggressively defending it. And you want somebody to think you're people of integrity? No, you're shitheads. Yeah. All right. You're really bad for the science cause, because you've just turned it into a religion, a dogmatic, archaic, habit-forming religion. Ugh.